Hi there. Welcome everybody for one more session here from Cloud Lunch and Learn. I'm Jackson Felden, one of the team members here in Cloud Lunch and Learn. And today, one more great presentation. We have here with us Marcel Lupo, just to talk about all about automate password rotation with GitHub in Azure. Actually, a kind of subject I need to get better. Never done any proper kind of study, any proper job on that subject. Looking forward myself here to get into this subject as well. For the new guys joining us today, please feel free to scan the code. And then, thanks to Microsoft, we always get some additional resources available on our on Microsoft webpage. And then take a second to just do a quick sign up. And then, using that link, you can jump and get some free additional material focused on this presentation. Marcel, I would say if you want to do a quick intro now, talk about you, what you have been doing lately on this kind of platform, and then a few seconds I will share your screen, and then I would say the show is yours.
Hi there. Thank you. Thanks, Jackson, and thank you very much for having me on the session today. It's a pleasure for me to kind of present to you today what I'm going to show you on GitHub. Basically, I'm a DevOps architect manager working at Avanade, and I love automation. I love Azure Cloud. I do a lot of my work is in DevOps, Azure DevOps, and now GitHub. I really am using GitHub a lot more, and lots of interesting stuff happening in the GitHub space. Constant innovations coming out, and one thing I'll be talking to you about today is GitHub Actions, and how I'm a big fan of automation. And just from my background, I come from more of a infrastructure operations background, rather than like a full-on like developer background. So a lot of the
it's kind of like me, to be honest. I never done any proper work into the kind of development side. Okay, it's good to know.
So but I've always been a lot into automation, and I will always look at how can I make life for myself easier through automation, but not just for me, but sharing that for anyone. And GitHub Actions is a really good way to share automation amongst the community, because it's open source. Anyone can use it, anyone can contribute to it. It's really amazing. It's really cool.
Okay.
So looking forward to showing you.
Okay,
that.
great. Looking forward myself as well. Okay, I will post that quick link here for you guys to do the registration in a few seconds. But Marcel, I think now it's time for you to take over, and I will keep my eye on the questions queue. If there is any question, it's better for me just to jump into your presentation and ask. Okay, let me just add your screen. Now I believe everybody from home can see your screen. And let's say the floor is yours. I will be here on the background. If you need anything from me at any stage, just let me know. Otherwise, just carry on.
Awesome. Thank you. Thank you very much. Alrighty. As you know, my name is Marcel Lupo. I'm a DevOps architect manager at Avanade. On the screen here, you can see as well my Twitter handle is @PWD9000, my LinkedIn page. I've got a blog as well that I regularly post to on dev2 /PWD9000. And there's also my GitHub page on the screen there. So as I said earlier in the intro, I'm going to talk to you about password rotation using GitHub Actions. Now, before I start with the demo, I wanted to talk a little bit first about what is password rotation? Why are we doing it? Why is it important? If you've ever worked in a InfoSec team, maybe an IT security team or operations team, the conversation always comes up about, you should regularly, for best practice, you should try and rotate passwords on a regular basis. Now, changing passwords basically limits their lifespan and can reduce the effectiveness of attacks. Changing passwords frequently can limit the time frame and validity of a password when it's stolen to be used in an attack. And passwords should always kind of be unique and never be reused and randomized. And that's basically why we do that. So if you can imagine you've got a big server estate in your environment, maybe in Azure cloud data center, and you have 100 servers or so, and you have to constantly change the passwords for those servers to kind of adhere to your governance or your security compliance for the local admin password, for example. So what's the challenges and risks with password rotation? So what I've seen, is a lot of this time, sometimes, it's not really scalable. If you're going to do manually changing hundreds of passwords, it can kind of pose a bigger risk because, passwords can be really hard to remember. And what happens is if you rotate passwords often, and it's like randomized and lots of characters, human nature is we won't always remember those complex passwords. And what you might find is people using those passwords or admins using those passwords might start noting down the password, this week's password is blah, 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 and they'll write it on a little post-it note or keep it in a text file on their desktop or something like that, because it's just, changes every week, right? So that's kind of a little bit of more of a risk, because anyone can then find that text file on your PC or that post-it note that's stuck on your computer screen, for example. Another challenge is if you're manually changing passwords, it's not really scalable. Imagine you have to change, like I said, 100 passwords every week, and you're doing that manually. You're just going to be sitting all day changing passwords all day, every day. And also changing them, manually can also kind of lead to a risk of them not being as randomized as they should be. So one thing I've seen, for example, is, you'll have a big server estate, and then you might have a password like, for example, your favorite actor or actress's name, followed by the number of the month, for example. And that would be this month's password for all the servers. All the admin passwords will be that for this month. And then next month you'll rotate it and it'd be the same thing, but maybe that next month's number. So, if it's August, say 08 or something like that. Now, this is a little bit of a big problem, because if a password gets compromised, attackers can kind of, if you use a pattern like that, a lot of passwords can be guessed based off patterns. So that's also really not good practice to do that. Now, how can we solve this problem? Well, automation. We can solve a lot of these problems through automation. So automating password rotation can alleviate administrative overhead. It can be, you can rotate your passwords very frequently, almost like on a daily basis, and it's like highly scalable. The solution I'll show you today is quite scalable as well. So, and using, a secure vault, such as an Azure key vault, those passwords can be stored safely, and the key vault kind of becomes like a control center, or a centralized area of control that you can maintain put the passwords in and store them safely there in that vault. You can also do this quite easily with GitHub Actions, and this is what I'm going to show you today. So, without further ado, I'll jump straight into a demo here, and I'll explain as well what we're going to do in this demo. So let me just enter here into my machine that I'm going to show you what we're going to do. So basically, what we need is a few prereqs before we can start. We're going to build in Azure. We're just going to build a key vault, and in that key, and we're going to create a service principal, or an Azure AD application and service principal that we're going to link with GitHub and GitHub Actions that's going to have access to our Azure environment. But what we're going to do is we're going to build a key vault, and in that key vault we're going to create secrets. So each secret key is going to represent a server in our environment. And then what we're going to do is we're going to use the GitHub action to connect to that key vault and look at all our server names, which is going to be keys in the key vault. And then for each server, it's going to generate a unique randomized password. It's going to connect to the VM that matches the name of the key or the server name. And it's going to try and connect to that server. And it's going to attempt to change the local administrator password to the password that it's generated. And then it's going to save that password against the key in the key vault. So that all we need to worry about is if we want to access our server on its local administrator account, we would just connect to our key vault and we'll just look up the server that we want to connect to and just get the latest secret from there. So let's start off. So I'm going to first start off here just by logging in to Azure, into my Azure subscription here. And I've also got it open here, so I can show you what we're going to do here. So we're going to first set a few variables here. I'm just going to create a resource group called password rotate demo. I'm going to create a key vault called pwd for rotate for demo. And my application name, or the account that I was going to use to link up my service principal to GitHub, I'm just going to call that GitHub pwd rotate demo. And I'm just going to use the location UK South because that's for me my closest location. So I'm going to create the resource group and key vault here. You'll also notice that I'm using the enable RBAC authorization mode. So if you've worked with Azure Key Vault before, there's two ways that you can give access to Key Vault. There's access policies, which is, you know, your get, list, set access policies that you can give people access to Key Vault. But more recently, the more modern way is to use the RBAC authorization model. Now, there is a reason why I want to use the RBAC model, and I'll go into it a little bit in a bit more detail later. But for now, I want you to just think about this. An Azure access policy, the drawbacks of an access policy is if you give someone access through an access policy, that access policy gives the group or person that you give access to, it gives them access to all the secrets in the key vault. If you use the RBAC model, you can now give access to individual secrets, which is really nice. So you can kind of, at the secret layer scope, give access to someone. So imagine this, right? We're going to have a key vault full of server names, and each server is going to have a password. But there might be a team that only looks after 2 or 3 servers, and they don't need access to the entire key vault through an access policy. They don't need to see my other team's servers' passwords. So what I can do is I can now actually permission my keys or my secrets only to those who need access over their servers. But anyway, I'll come back to that. But so this has created our resource group and key vault. So if we take a quick look in Azure, we'll see here that I've got my password rotate demo resource group, and here's my key vault. And as you can see on the access policies, I have my role-based access control. So the next bit that I'm going to run is I'm going to create that service principal, that AD application and service principal that I'm going to use later on to hook up with GitHub. And I want to show you something here. I'm going to give my service principal access, RBAC group access called Key Vault Secrets Officer. The reason I need secrets officer is because my GitHub action is going to connect to the Key Vault, and it's going to need the ability to obviously read the secrets and also set secrets because it's going to generate random passwords. So I'm just going to create this, and you'll see here I'm using SDK auth at the bottom here. I'm just going to quickly run that. The reason I use SDK auth is because you could just ignore that. It's just a warning there that this option is going to be deprecated at some point. But you'll see that this is actually going to spit out here for me a JSON block. And I'm just going to make a note of this JSON block here because I'm going to need this when I'm setting up my GitHub repo. Now, I only need the first kind of 4 line items here, so I'm just going to get rid of that. My app is going to be, that's going to be the app ID, the secret, the subscription, and the tenant. I'll keep that to one side at the moment. And we can actually quickly have a look as well in Azure. Let's take a quick look at our app registrations. And we will see that my app registration here, GitHub PWD rotate demo, has been created. And if I just jump back to that key vault real quick, and we look at the IAM permissions here, you will see that I have my application has got, let me try and make this a little bit bigger here. So my application has got Key Vault Secrets Officer on my Key Vault. Now, we're almost done with the prereqs. So the next bit I'm going to run here is I'm just going to give myself access to the Key Vault, because I'm going to set up server names here in just a moment. That seemed to have failed, but okay, sorry, yeah. So what this command here is doing, I need to make that app name. Sorry, what this command here is doing is that service principal that we've just created, we need to give that extra access. So what I'm going to do here is I'm going to give that app access to basically to my subscription as virtual machine contributor. The reason I need virtual machine contributor is because my GitHub action is going to, remember, it's going to connect to a server and it's going to try and rotate the password for that server. So the minimum permission that it needs to do that is virtual machine operator. Now, I'm scoping this permission to the subscription. You don't have to do that to the subscription. If you've got all your servers in a certain resource group, you can just scope the permission to that resource group. But for me, I don't mind, I'm just going to do it to the whole subscription. I'm going to give my principal the virtual machine contributor. And then the next bit is just giving myself access to the Key Vault, like I said, because I'm going to have to set up some secrets. So let's take a quick look at that. So if we look at the subscription, and I look at my IAM permissions on my subscription, and I just go to this resource, we'll see that my virtual machine contributor, I've got my GitHub PWD rotate app here, and also to my Key Vault, I should have access now as well to create secrets. Now, the next step I want to do, and the last step I'm going to do in Azure, is let's have a look at, I've got a couple of virtual machines here. They're all running. I've got a PWD VM 01, 02, 03, 04. So what I'm going to do is I'm going to take the first server here, and I'm just going to go back to my Key Vault, and I'm going to create a secret here in my Key Vault. Now, you can also, just to show you, you can also import a list. So if you've got a whole list of servers, you can also import those server names. All I'm going to do is I'm just going to create the server name as the key, and I'm just going to put some random string here. It can be random because my GitHub action is going to rotate that for me anyway. So just to populate the Key Vault, I'm just putting in anything here. I don't even need to think about what I'm putting there, because I'm just kind of creating my keys. So there's my first server. I'm going to do the same for the second one. Just going to make a random password there. I'm going to do the third one. Just do a random password there. Do a fourth one. Like I said, you don't have to do this like manually like I'm doing it here. If you've got a big server estate, you can just kind of import your server names in here, or maybe write a script that can do it for you, or whatever. You just need to do it once off just to kind of build it up. Now for the fun part. Now we're going to do the GitHub part. Now, I'm going to create a new repository here. Let's call this demo password rotate Azure. I'm just going to call this my private repo to rotate.
Hi, Marcel. Can I ask a quick question?
Sure.
Yeah, just wondering, for the guys who are watching us now, for this work you are doing on GitHub, do they need any special license? Do they need to pay anything, or let's say just a basic, access to GitHub?
Yeah, sure. So this is free. You can go onto GitHub, open it. You can have an account on GitHub. You don't need GitHub Enterprise to pay. So to use this is completely free, and it's completely private as well. So
okay.
So I'll show you here, but yeah, for basically for this, you won't need any sort of licensing. You can go on GitHub right now and kind of just create an account and do this right now. It's absolutely free, and you don't have to pay anything for what I'm going to show you here. So
okay, that's great. Yeah, thanks.
No worries, Jackson. So you basically, if you've got an account on GitHub, you can just go and create a new repository, code repo. Our repository is not going to contain much stuff anyway, so you'll see in a minute. So I'm just going to call this here demo password rotate on Azure. It's a private repo to rotate passwords for VMs in Azure. And I'm going to make this private because I don't want my repo to be open on the internet for anyone to see. This is kind of just for me in my own organization, or if you're working in a large company or organization, they might have GitHub Enterprise or an org that you can do this in. You can create a repo in. For smaller projects, you can use just use any GitHub repo that you're allowed to use basically in your environment. I'm going to add a README file. I'm going to add a gitignore file. You don't have to add these. These are just like basic files for repos. My license, you don't have to put it. I'll just put the MIT license. It doesn't really matter. So I'm just going to create this repository. And you'll see there's the three files: the license file, the README file, and the gitignore file. Now, to use GitHub Actions, what is a GitHub Action? So GitHub Action is basically, it's almost like, imagine a serverless script. So GitHub Action is basically going to, when it runs, it basically spins up what's called a runner, a virtual machine, and it will then run something. And then after the run, it will destroy itself. So it's kind of, you're not really paying for anything. It's just, it's free. It's, GitHub Actions, there is a limit to how many minutes, and I can't remember exactly what it is on the GitHub free account, but it's quite a lot. So you'll never run out of minutes doing, especially this sort of rotation. But what we do need is we need to kind of somehow connect our GitHub repo up with Azure. Now, remember we created that service principal, and that service principal has got Key Vault Officer on our Key Vault, and it's got virtual machine contributor on our subscription. Those are the two permissions that service principal has. And here is the details that it uses. So I'm going to copy this JSON block. Just going to copy that. And in my project, under settings, I'm going to scroll on the left. Here is a section called secrets. I'm going to add a repository secret. And I'm going to call my repository secret Azure credentials. And I'm just going to copy that JSON block in here. I'm going to add that secret. Now you'll see that once this is added, I can't look at it. I can only update it or remove it. So just a word of warning: if you add this JSON block, make sure maybe you can even put that in your Key Vault if you want to keep it for reference again. But just be aware that once you've put it in here, you cannot go back and look at it or change it. Go back and look at it. You can only update it. Like, let me show you. If I click on update, you see it's gone. I can only update it with something new. So there's my Azure credentials. Now, if I go to the Actions tab, you'll see here that there is no actions, and you can kind of configure a simple workflow. A workflow is basically that script, kind of that runner that spins up, that's going to create a script and will run that script. But what I'm going to show you is, because I've recently created a marketplace extension called Rotate Azure Virtual Machine Passwords that you can kind of get from the Actions Marketplace. So if you, for example, go to the Actions Marketplace on GitHub, you can just type in password rotate or something like that, and you'll see my GitHub action, which I've created here. And I'll show you a little bit more about the GitHub action here in a minute. It also shows you here what we've just spoken about, how to create a key vault and populate it with secrets. Now, how to use this, I'm just going to copy this code here. This is basically an example workflow. But what we're going to do in our repository, if we go to our repository, we're going to create, basically going to create a folder. Now, here's something really cool that you might not have known about. But if I'm on the root of my repository here, and I press the just dot on my keyboard, I'll show you here what happens. By just pressing dot on the keyboard, it's actually opening up an instance of Visual Studio Code in my web browser. So I don't need a virtual machine or Visual Studio on a machine or anything. I just go to my repository and just press dot, and you'll see here I've got Visual Studio open in the browser. It's pretty cool. It's very similar to GitHub code spaces, but let's do this here real quick. So I'm just going to create a new folder, and I'm going to call this .github. And under .github, I'm going to create another folder. I'm going to call it workflows. Now, this is a very standard documented way. This is a very special folder structure. .github/workflows is where we create workflows. You cannot call this folder something else. It has to be called .github/workflows. And in this folder, we're going to create a workflow, and we're going to call it, let's call it password rotate. And it has to be a YAML file, because workflows are kind of defined in YAML. So I'm going to go back to the marketplace extension I built, and I'm just going to copy the code here, and I'm going to paste it here. And you'll see that I'm given my workflow name, update Azure VM passwords. You'll see here that I've got an on. Let me try and make this a little bit bigger. Sorry, I realize it's a bit small. I can't seem to make it look a bit bigger. Sorry if it's a bit small, but let me try and open this in something that's a little bit more visible. So our GitHub workflow is basically has got a name, and then we've got an on field. Now the on field is like a trigger. Workflow dispatch is going to let us run the workflow manually, but we also have a schedule that we can run, a cron schedule. And this cron schedule is saying basically run this workflow on every Monday morning at 9 a.m. You can change this. I mean, you could change this to run every day if you want. It's just a cron job. You can, I kind of use this website. You can kind of check it out if you like. I think it's called Cron Guru. It's pretty cool. Where you can kind of put in your cron job, and it'll tell you, it's going to be every Monday at 9. And you can play around with this. You could say, oh, maybe I want it, every Wednesday, for example, or maybe like every day, at 9 a.m. I want to rotate my passwords on a daily basis, or the first day of the month. It's up to you how often you want to kind of rotate your passwords here. Then you've got the job, which is like a stage, and we're going to say it's not publish, it's more like rotate PWD is going to be our job name. This can be anything, basically. It's just the name of the job. It's, we're just calling it rotate PWD. And here's where you can say what it runs on. Runs on a Windows image. Now, here is the bit that we're going to have to change. It's an environment variable where we're going to have to give the key vault name that we just talked about. What this workflow will do, it's got a few steps. So it's going to check out the code of the repository or clone the repository. It's then going to log into Azure with that credential that we set up on the repository. This JSON block we just spoke about that we created the secret for. It's going to use this GitHub action to pretty much log into Azure. And then what it's going to do is it's going to run that public action using the environment name of the key vault. Now, if we just quickly jump back to Azure, our key vault is called PWD for rotate demo. I'm just going to copy that name, and I'm going to go back to my repository, and I'm just going to update the key vault name here on my workflow. And that is the only change that I need to do. So I'm just going to commit this change and say update key vault name. I'm going to commit that. And if I press escape now, so I go to back, press the back button. This will take me back to my repository. And if I refresh my browser now, you'll see that I've got that GitHub workflows folder. And in that workflow, I have got, I made a spelling mistake there. PWASS password rotate. So I can correct that real quick if I just press dot again here. And I will just go and just quickly rename that file. Password rotates. I'll just say update file name and save that. Go back. Now, what this does basically, because we've got a file here, which is our workflow. Now, if we go to the Actions tab, we can see our workflow is here. Update Azure VM passwords. And remember, I told you that the workflow dispatch trigger will allow us to run this manually. So what I can do now next is click on run the workflow, and I can say run workflow. And what this is going to do, remember, it's going to check out my code, it's going to connect to Azure, and then it's going to, basically what it's going to do is it's going to loop through the key vault. It's going to connect to my key vault here, and it's going to loop through each of these servers' names. And it's going to generate a password for each of these servers, and it's going to try and connect to the server, change the password, and then it'll save the password against this key vault key. Key vault secret key. The value will be the password. So if we take a quick look at the run of the workflow, let's take a quick look here. You'll see the repos being checked out. It's now trying to log into Azure using that secret Azure credentials secret that we set up. So it should connect to Azure in a moment. Takes a little bit of time. We'll just give that a bit of extra time there.
And Marcel, can I ask you another question? Don't want to put you on spot, but anyway, just for me to learn as well.
Sure.
Yeah, let's say for exactly, part of this demo you are doing, before I asked if there was a need for any special license on GitHub, and then the answer was no, everything is for free. Let's say from the Azure side, of course, I'm not counting the cost to run the virtual machines and so, but the cost to have this implementation done, basically we pay for the key vault, or what are the other services that must be paid in order to do this password management and things like that?
Yeah, so all you need is a key vault. So the only cost you will have is for the key vault, basically. Well, obviously you have the cost of your Azure infrastructure, like your VMs if they're
Yeah,
running,
exactly. Yeah.
things like that. But you know, the GitHub side, if you have a free account, you have limited amount of minutes that you can use GitHub actions. Like
Okay.
these scripts take, I mean, this is going to take about 2-3 minutes to run. You have quite a lot of free minutes a month to use in the GitHub free account. I can't remember the exact amount, but you can kind of look that up. But you don't pay for this VM that's running this script in the background. It's kind of, you know, free. Obviously, you're limited with the amount of minutes that you can use a month. But yeah, the cost of the key vault is going to be minuscule because you're kind of just you know, you're connecting, reading the secrets, and then just setting a secret per server.
Yeah,
so the cost's going to be very minimal here. It's kind of a very frictionless as well, because you don't have a server that's running constantly to update passwords. It just depending on how often you run this, you know, I run it every Monday morning at 9 a.m. You know, in a whole month, you might be looking at a few pennies probably.
Okay, that's nothing. Yeah, for the return you can get from that configuration. Yeah. Okay, that's great. Yeah, thanks for the answer.
No worries, no worries. So let's take a quick look here what this is doing here. So we can see here that it's creating an array of all the VM names in the key vault. And now it's going to look through each VM and change the local administrator password. So it's found the first VM, and then it's checking, is the VM in a running state? If it's in a running state, it's going to generate the password, and then it's going to update the key vault with the new password. And then it's going to say to me if it's updated the VM successfully or not. Now, it's going to run through each of the VMs here. As you can see, it's got VM1 already. It's got VM2, and it's now in VM3. Let's test this quickly. Let's see if we can connect to our VM. So let's take VM2, for example. If I open a remote desktop session here, and remember, this is what I was saying to you earlier, using the RBAC model, just quickly before I do this. If you have a team member or a group of members that is only looking after server 2, you don't want to give them server 4 because server 4 might be a different team. But what's nice about the RBAC model is I can go into this server and I can give access now on this password. So I can say, Joe is looking after server 2. He's not looking after server 3, 4, or 5 or 1. So I give Joe access now just to get the secrets for this server. So when Joe wants to connect to his server, he can have access to the key vault, but he will only see his server here. And he doesn't need to worry about his password changing or who changes it or what changes it. This is automated for him. All he cares about is, I need to connect to my server to do something. He can come to the key vault. He will see his server here. He will connect to the server, and you can see here his current version. If I go in current version, I look here at the bottom. I mean, I don't have to show the value, but I will show you for the purposes of this demo. I could just copy it, but you see, there is my password. It's very random, very randomized password. If I connect to my server, which was VM2, I can now go pwd 9000 admin, and I'm just going to copy that password and paste it. And you'll see that I can connect. Hopefully it will let me in. And you see there I am connected to my VM. The password is all good. And I'm connected. Now, let me show you something different. Let's quickly jump back to the GitHub action. I think it's probably run through all of them now by now. Yes. So if we go back and we go to actions, we can see that it ran 7 minutes ago. If we look here, we can see that it's run perfectly fine, no problem. Now let me quickly go here and turn off I'm going to turn off server 2. And what I'm going to do is I'm actually going to delete server 4. So I'm going to go to the resource group, and I'm just going to delete server 4 here. Goodness me, I cannot see the delete button. Let me just make this a bit smaller. There we go. I just want to quickly show you what happens if a server is off and if a server is missing completely. Now, this also depends if you've given access. But remember in the beginning, I said when you're creating that service principal, you can give the access either to the subscription or you can give the access to a resource group. So depending where you've given the access, I want to, by deleting a server is almost like having not access to the server. So I want to show you what happens if we run the workflow again, but this time server 4 is gone. We've decommissioned server 4. It's no longer in our environment. And server 2 is not on, it's just off. So let's just give this a moment here to finish. I think it should be good now to run the GitHub action. So I'm going to come back to our actions. I'm going to go again on update VM password. I'm going to say, and what's nice about the workflow dispatch is in your environment, you remember you have a cron job that runs every Monday at 9 a.m. Let's say there's been a compromise. Say a server's been compromised, and you might have had this situation in your environment. Your InfoSec team comes running to you and say, one of our servers' passwords been compromised. We need to change all the passwords today. Okay, fine, not a problem. You can run this automation manually anytime. It doesn't have to be on a schedule. There's been a compromise. You can just come here. We're going to run this again manually, and it's just going to loop through all our servers and change the password. So no more like panic IT sec people running around changing passwords. You just come here, you press the button, and you go for a coffee, and that's it. But let's take a quick look now here with one of the servers actually being off and the other server has been decommissioned. So say, for example, you do have, if I just go back to the Key Vault here, we have a list here of servers. If the servers are on and running and the GitHub action has got access to the server, then obviously it will change the password and it will update the secret in the Key Vault. If the server is not running, you will see here, I can come back. It's taking a little bit longer, but to show you on the GitHub action, if the server will be skipped if it's not running. So you'll get a warning message like this. The server VM is not in a running state, so it's skipping it. And it will just go to the next server. And if the next server is also off and deallocated, it just skips it. It just means that if you have servers that's off in your environment, the automation will not take effect on them. It will just pass them. The server has to be on and running for this to work, for this rotation to take place. Now, if a server is decommissioned or the action does not have the access on the VM, it will just say that the VM is not found, like that. So we should see that happening here in just a moment. I also wanted to show you that not only, there is another option here that I've not actually shown you. If I just quickly go back to the action here, by default, the password character length is going to be 24 characters. And you can, so basically the action has got inputs, and obviously the input is the key vault name, but you can also put an input called password length. Now to do this is I can go here to my action, and remember my key vault name is from this environment variable here. I can actually put here an extra key that says I want the password length. The default is 24. But if I want something different, I can have 34 characters if I want. So I can make the length of password configurable. If I don't specify anything, it's 24. 24 is a good number. It's quite a long, complicated password. 24 characters, and I can show you as well. If we look here, server 3, you see that's going to be 24. Sorry if I just make the screen like here, so you can actually see. You see here my secret is 24 characters long. So if I go back to the GitHub action that I ran manually, you'll see that server 1, it's changed the password. Server 2 was not running, so it skipped it. Server 3, it found and it changed the password because it was on. And server 4, it's saying VM not found. Now I know that I just deleted the VM, so I could just go back to my key vault, and I know I deleted VM 4. I don't need this key anymore. I can just delete it. Because the server is decommissioned, I don't need to worry about it. I just delete the key, and that's basically it. You can use this today just to show you when it comes to the password rotation, and in case you wanted to know what is happening behind the scenes. Basically, what's happening behind the scenes is we're generating a random character set. And the random character set is 64 characters of random numbers, letters, and anything. And then what we're doing from that is we're randomizing it again, but we're saying use the count of whatever our length is. So for example, if our GitHub action length was 24, we're saying from that character set, use per server, use a different combination of the character set. So this is what's happening basically when we are triggering that workflow per server. And if you want to have a look at the GitHub action in the marketplace, again, you can come to the action here in the marketplace, and you can actually, because it's all public, you can actually come and look at the GitHub action on my repository to see exactly how it's doing it, the PowerShell script that's creating the character set. And actually the script, it's just the PowerShell script that is connecting to the key vault, looking if the server is running. If the server is running, taking that amount from the characters from the character set, trying to set the password on the key vault, and then setting it against the corresponding key in the key vault. So you can come and look at this code if you're interested in wanting to see how this how this action is actually working. This I'll jump back here. How this GitHub action is actually doing what it's doing behind the scenes. So I'll leave that with. We've got 10 minutes left, so I don't know if anyone has got any questions, maybe, or Jackson, maybe you've got a few more questions that you wanted to ask regarding this.
Yeah, I think you explained too well. Then there are no questions on the queue at the moment.
Okay, perfect.
Yeah, because myself, working on the security side is really a nightmare to try to manage all the passwords on servers and make sure you don't duplicate the passwords, make sure you kind of randomize the passwords and so on. And definitely after your presentation, the guys watching us here can walk away with some, let's say, better ideas how to manage that and to increase the security and kind of decrease the amount of work done in terms of managing the random passwords. Yeah, that's really great solution.
Yeah, and also, this technique, for the guys out there that is like, familiar with GitHub Actions, how to write, I would encourage, write your own actions. This concept that I'm showing here, I'm showing it for virtual machine passwords. You can do this sort of thing, this concept, for anything. Imagine if you have SQL servers that have database connection strings you have to maybe rotate. Maybe you can do something like that with with GitHub Actions that do, that rotate not your server passwords, but maybe some sort of other thing that you need to rotate passwords for. The concept from here that I want to kind of show is utilizing Azure Key Vault as a central management store, and then just automating your rotation and keeping those rotation inside of Key Vault. But yeah, you can apply the same concept on anything. You just have to maybe think a little bit out of the box, maybe have a plan, and yeah, you can kind of do some really cool stuff with GitHub and Azure combined. What's really nice for me about the solution is it's very cost effective. It's quite secure. Like, of course, when you're making your GitHub repo for something like this, don't make a public repo that the whole world can see. Make a private repo. It's only you that will see it.
Yeah.
I mean, these are some pointers that I can give you. When you are doing stuff in source control, don't put secrets in source control. We put the GitHub secret for the credentials. We put it in GitHub secrets. No one can see those secrets. But yeah, I mean, that's, if you've got any questions about this, if there's no questions now, you can see my Twitter. If you go back to the beginning of the video, come and ask me on Twitter or send me a message if you've got any questions. Happy to answer and maybe even help if you want to invent something new, something cool.
Get started on this task. Yeah, that would be great. Yeah. Okay, awesome. I think if you don't have anything else to share, just want to say thank you. And let me just bring the code again for everybody watching us now. Again, if you could just do a quick registration, follow the link to get some additional material regarding this presentation. And please, keep your eye on our webpage, our LinkedIn page and Twitter to see the upcoming sessions. We are running weekly sessions with different subject. And I believe, Marcel, you are back at some stage in February or March. I saw your name a couple of times. That would be a pleasure to have you back here with us again.
Yeah, actually, for the next 4 months, I will be on every last Wednesday of the month.
Okay, that's brilliant.
Yeah.
Just so to keep yourself busy and keep all the learning thing, moving forward for everybody.
Yeah, I've got some cool sessions coming up.
Yeah. Okay, thanks everybody. Thanks everybody watching us from home, and thanks again, Marcel, for the great presentation. And yeah, hopefully we will see you again and everybody from home next week again. Okay.
Thank you.
Thanks everybody.
Thank you very much.
Bye.
Thanks. Bye-bye.